So hi everyone, my name is Fraser Kane. I am the publisher of Universe Today. It's your weekly space hangout for Friday, May 3rd, 2013. And we have so many stories today. Again, we've got the brightest gamma ray burst ever, the test of the Virgin Galactic spacecraft, a cool storm on Saturn, collisions of galaxies spotted by Chandra, maybe a test of the X-51, an upcoming solar eclipse, and more and more and more. So we're going to get cracking. You can meet everybody who is joining us this week, and we've assembled an enormous team to talk about an enormous number of stories. So let's just get through it. So we've got Alan Boyle from Cosmic Log.
Greetings.
Awesome. We've got Amy Shiratitle.
Hello.
From Vintage Space and other places. We've got a new person joining us this week, which is David Dickinson.
Hey there.
David. David has written, you're at Astro Guys and also has done some writing for Universe Today. So awesome. We've got Jason Major.
Space.
Space. We've got Dr. Matthew Francis. Oh, he's muted. Still muted.
There we go.
There we go.
Two places to mute.
I know. And we've got Dr. Nicole Gallucci.
Hello.
Who is going to be producing this show and posting lots of cool pictures of all of the stories, posting up the story links and pictures as we come across them. So
all the clicking.
All right. And Alan, I kicked a story your way. Is that fine? X-51? You want to talk about that?
Sure. All right.
Okay.
You want to start with that?
No.
Oh, all
I
right.
just want to make sure that you're okay to do that. If not, that you can prepare yourself mentally and emotionally.
I'm ready.
For that. Okay.
Mentally and
good.
emotionally.
No, I think the first story we'll talk about is this really bright gamma ray burst, the brightest one ever. Dr. Francis.
All right. Well, one moment. Let me bring up
I
the
can do that while you talk.
Okay, well, that works
Share it while you talk.
You only have to think and talk.
Yes.
You don't have to also click and share.
All right. Well, I will take it away then. All right. So this is the brightest gamma ray burst yet seen, and it's also the not coincidentally the longest duration gamma burst yet seen. So gamma ray bursts are, to our best knowledge, the explosion of very, very massive stars. So not just a supernova, but a big hypernova. So this was spotted on April 27th. By the way, gamma ray bursts always have these really kind of a license plate name. So this one is, I even had to write it down, GRB 130427A. And that was found
It's
on
just
April...
the date.
You're right. Wow. So it was the first one slain on that day. I never made that connection
Really?
before.
Oh, okay.
Theorist. Okay, but anyway, it was the longest, and but what's interesting though, of course, is because it's so bright, that means it's relatively close by. Relatively in cosmic terms, it's about 3.6 billion light years away. But a lot of gamma ray bursts are a lot farther away. So this one is very interesting because it was long enough that it could be observed both by the orbiting Fermi satellite, gamma ray satellite, but it could also be observed, follow-up observations by ground-based telescopes at the same time, which almost never happens. Usually gamma ray bursts flash and then fade, and then you kind of have to work backward and track them down. But this one actually successfully spotted, and so very exciting stuff. Means there's going to be a ton of data from it. Great thing, and it's one of those. One of those, oh my God type. I'll clean up what I was going to originally say. Oh my God moments. Really, really bright and awesome.
What was the visual magnitude on that?
I could not find optical data on it.
Okay.
I will see if I can track that down, and then we can add it later. But I couldn't. The press release just came out today,
Yeah.
and it doesn't link to a paper. And there's nothing on the archive about it. So I'm going to see if I can find a visual magnitude because I wanted to know that answer.
What about
too.
Astronomer's Telegram? That might have it.
MIHL.
Yeah, I'll check.
Daniel Fisher, Cosmos for You, has been tweeting about this for days. So I think he links to a couple of the telegrams. So
Excellent.
I'm wondering if any imagers might have caught it, just on their random exposures.
Well, there was one
possible.
other gamma ray burst that hit visual, like naked eye visual magnitude a few
Yeah.
years
Yeah.
back,
I
so it's
remember
not
that one.
impossible.
Yeah.
Now, I mean, if I understand correctly, right, gamma ray bursts, the cause is essentially really large stars going kaboom, or, compact objects colliding with one another. So,
Right.
was there anything special, or was it just a really extra big star that went kaboom?
It's just that it was extra big and extra long. So the fact that we've got more data from this than before. I'm not sure why it's just hitting now, since it happened on April 27th, why it's just hitting NASA press releases now. But
well, I mean, a lot of the times this raw data is totally available, but
Yeah.
it takes sort of a certain mindset. Someone's got to be actually looking through it and trying to get a sense of it. But, if it finally makes it through NASA's press release, then they're going to take it and they're going to write it up, and then we all start reporting on it because we weren't looking through the raw
Right.
logs from from the space telescopes, which maybe we should. I don't know.
Although actually, if I can pick up on something that Fraser said, we can definitely rule out the possibility that this was another source of gamma ray bursts is two neutron stars colliding, two pulsars colliding. And the reason we can rule that out in this case is because the duration of the explosion was too long. Gamma ray bursts that come from collisions are short duration, and this was not that. So we can rule that out.
Fantastic.
And they expect to find, they expect to be able to see the supernova remnant supernova of that caused it within a month.
Yes, which would be awesome.
And I think if you want to get a sense of the scale of like how much damage is getting done by a gamma ray burst, you should definitely pick up Phil Plate's book, Death from the Skies. He's got a great chapter just on gamma ray bursts, how you get essentially this horrible beam of energy that goes halfway across the galaxy. There we go. And
Awesome book.
strips away your atmosphere in a heartbeat. So, a gamma ray burst, even if you're a whole half galaxy away, it is no protection from something this powerful. So amazing. All right, well, let's move on. We get so many stories. So Virgin Galactic did their first power test, and they broke the speed of sound. Amy.
Yeah, that happened on Monday. So Spaceship Two is launched underneath a mothership. It's not actually launched on a rocket like we're sort of used to seeing in spaceflight. So the mothership is flying. It drops the Spaceship Two, and on Monday it ignited its engine and actually went supersonic. I don't actually, off the top of my head, know how fast it went. If anybody has that link, they could pull it up. But it did go supersonic for about 16 seconds, I think, before its engine shut out, and then it came down for a landing. So that's a huge milestone because, of course, when Spaceship Two does eventually launch from a mothership and do the same trajectory to get into orbit, it's going to have to do that supersonically. So that it actually went supersonic on Monday is a pretty big milestone. So that's fun.
Now, Alan, were you there when they did the first test for Spaceship One? Did you actually see it get tested?
Yeah, 3 for all 3 flights. Yeah, June and then 2 kind of in the September-October time frame. Yeah.
But there wasn't a lot of advance notice that this was going to happen. It was pretty quiet, and then they did their test. I saw some rumors and sort of conversation that was going to happen, but they definitely didn't make a big to-do about it this time around.
No, actually they made more of a to-do about it this time around than they would have under Bert Rutan's tenure, because Bert was always, he didn't want to he wanted to make sure that it really worked, and so he didn't want to have all these journalists breathing down his neck as they do this stuff. So this time there was a little bit advance notice, but there's always a chance that they could call off the test. And even if a pilot sees that something doesn't look right before they do the drop, they don't have to light up the engine. They can just glide back down to a landing. So they want to give themselves as much leeway as possible.
And so where are we on the timeline now compared to actually paying passengers getting a chance to fly in space?
Well, they're going to do a series of tests. This was the first test. They'll kind of build up to actually putting the test pilots above the 100-kilometer altitude mark, and that will be officially they're in space. But they they expect that that will happen by the end of the year, but it's going to take a little while longer for commercial operations to start up, and they expect that commercial operations will be in a different place at the Spaceport America space facility in New Mexico. So now they're saying that it's going to be early next year that Richard Branson and his family are going to climb aboard and be on that first commercial flight, but a lot of people have told me that it could take longer than that. It could be, you know, even way back when some people were betting it was going to be 2015, other people were betting it was going to be 2017. So it's nice to be optimistic, but also to be realistic and don't expect, you know, don't set aside your vacation time yet for next year.
I heard they've also raised the price, right? Like, I think it was before it was $200,000 for a trip, and now I've heard they've raised it to $250,000.
Yeah, they're saying that it's likely that they will raise the price to $250,000 for a seat, and that may be sort of a marketing thing so that you get people interested in kind of getting the $200,000 deal. But eventually, everyone at Virgin Galactic has talked about how the price should eventually come down to about the price of an SUV or a very expensive vacation on Earth. So this is really kind of more of a marketing, let's talk about a price raise. Maybe they will raise the price for a while and then see how the market goes once you've got the early adopters flown.
So just a show of hands here, who would fly on Virgin Galactic?
Yeah, you bet.
Will you give me $250,000 for the ticket?
Yeah.
That's
free
the
ticket.
assumption,
Free
sure.
ticket.
It's got to be longer affordable.
So I was just noted on Facebook that the Spaceship Two hit a top speed of 2,500 miles per hour.
Yeah, according to Robert Herrick on YouTube, they hit Mach 1.2.
Oh, nice.
Oh, right. I forgot to mention that people can comment and and give us updates and answer our questions as well. So if you're watching this on Google Plus in the event page, you can post your comments there. If you're watching this somewhere in the streams, you can. I don't know if you got that one, Nicole, the one from your feed. Okay, yeah.
Oh, I don't know if I shared it, but I have it.
Yeah, you can get it from if it's Nicole's stream, you can post a comment there. If you're watching this just somewhere embedded, you can use the hashtag. What are we using?
Space Hangout.
Space Hangout. Okay, use the hashtag Space Hangout. Or if you're watching this on YouTube, which is kind of the safest place to sort of comment and make sure your comments get seen, you can post a comment there just on YouTube. Just click Watch on YouTube, and then there'll be lots of comments there.
As we go, I'll be posting links on the comments of the event page, but I'll also include them in the description of the YouTube video when we're done. Okay,
great. All right. Okay, so now this is cool. This picture was all the rage this week, and I know, Jason, you report on this amazing storm on Saturn.
Yeah, this is some really neat stuff. Well, let me lead up to it before
I'm sure Nicole's digging up the picture as we talk. So,
do you want me to hold off on the picture? Do you want it to be a reveal?
Well, hold off on the picture. Hold off on the picture.
Get it ready.
So, well, you know, Saturn is a very windy planet. Okay, it's a gas giant. There's no solid surface. There's no liquid oceans under there. There's nothing that's going to affect the wind from a ground standpoint, and it has a lot of internal heat that's powering these powerful winds. And then the storms themselves, the eddies, the shears between the jet streams, the big bands that go up and down the latitudes of the planet, those power the winds as well. So basically, everything's just blowing around on Saturn all the time, permanently. Well, right at the top, right over the North Pole, there's a 1,200-mile wide hurricane, this huge cyclone that's just churning and churning away up there. Clouds get caught up in it, smaller storms start spinning around in it, and basically it's like this big vortex that dips down into the cloud bands, into the atmosphere on Saturn. And last November, Cassini managed to get a shot of that as its new trajectory kind of took it up out of the ring plane and around the poles of Saturn. So as the sunlight's hitting the northern hemisphere, it's lighting all that stuff up. Charging up the storms with a little extra solar energy, and the photos that came back, in fact, I remember when that photo came back because I just happened to be up looking at the Cassini stream that day, and these new raw images came in, and it, I mean, literally knocked me out of my chair. I mean, it was just, I had to write a post about it. That was in November, so just this week, NASA put out some recolored images of the same exact shots that came out in November. Nicole, yeah, there it is. And so if you pop that up there, you can see this storm, this huge hurricane, and this thing's spinning right over Saturn's North Pole. What we're looking at here is the red clouds. Now, keep in mind, this isn't true color. So the storm isn't really this blood red color like something out of some, you know, H.P. Lovecraft novel. I mean, it's you know, in reality, the Saturn storms are much more tan, and up in the northern hemisphere, some icy blues and greens. So, but what this color does do is it lets us see a lot of the contrast in the cloud formations, and we're looking into something that's diving deep into Saturn's atmosphere. The clouds are at a lower level than the red clouds are at a lower level than the green clouds outside of them. So, you know, they're further down, and of course, the deeper red you go, the more you're looking down into Saturn's polar atmosphere. So
it's amazing how much there is that almost like an elevation change. Like you're really looking down.
Yes. Down
into these clouds, and the clouds are whirling. It's like a
Grand Canyon.
Yeah, like
into, you know, being seen at sunset. So it's just, you know, it's just beautiful. So this image just basically knocked everybody's socks off this week. You know, almost the same way as they first did when they came out at the end of November. But these recolorized versions, they've been cleaned up a little bit. You know, had some of the hot pixels removed and stuff like that. So the impact of it is just amazing, and it just shows us the type of incredible atmosphere that we're seeing on Saturn. You know,
I
don't
love the
forget
scales.
that, like Jupiter, it has storms too, and it's really exciting stuff. And we can only see these images because Cassini is on its new trajectory that's up and over the poles. So that's fantastic. And you know, now that it's approaching summertime on Saturn, the poles are getting more light, so we can see these things.
I love the scales of the like you have this little guy here, which mimics the larger storm. All these different scales of the turbulence.
Now, keep in mind that storm up there, you know, side to side, it's about 1,200 miles. So that storm itself is basically almost, you know, halfway across the United States. It's a big storm. That's a giant hurricane.
Yeah. Cool. I've got one question. Rod Mole wants to know, what speed are those clouds moving? I don't know if anyone knows.
The entire storm structure is moving around Saturn's North Pole around 300, a little over 300 miles an hour.
Wow.
Now that's actually slow compared to other wind speeds on Saturn. Around the equator, you're looking at 1,000, 1,100 miles an hour that those wind belts are going. So that's actually kind of pokey for Saturn, but still, it's a really powerful storm here on Earth.
It would be like a Category 8 storm on Earth, I think.
Oh wow. Okay, cool. So now, Nicole, we're going to ask you to walk and chew gum at the same time here and present a story about a galaxy collision as seen by Chandra.
Absolutely, I can do that. So Chandra X-ray Observatory is the flagship X-ray telescope, space telescope that is a project of NASA. And one thing that X-rays give, that you can see in X-rays really well, is hot gas, really hot gas. Now, when you look at a galaxy, you think, okay, the galaxy is made of all these stars and stuff, and we know there's a lot of dark matter in there as well. But actually, when you've got galaxies in a cluster, the stuff that makes up the most mass of normal matter, not including dark matter, is this hot X-ray gas. And so what we see here in this image that I'm going to screen share while I talk and chew gum at the same time. Actually, I thought about chewing gum. Oh, thank you. Excellent. Thank you, Matthew.
Because I keep being right about it.
Yeah.
So this is a composite image of, so the purple is the X-ray gas from Chandra. And so this is 7 million degree gas, really hot gas. And this is going around these galaxies, these two spiral galaxies that have collided. And I'm not sure where the optical data was taken from. I should be able to find that at some point. But that was taken So that's what these two galaxies are colliding here, two spiral galaxies. And now what we think happens is when two spiral galaxies like that collide, first of all, the stars don't collide, but the gas does. And when the gas collides, it makes more stars. So it's undergoing an intense period of star formation. That is throwing up all kinds of gas out into this massive halo. And what we think this will eventually turn into is an elliptical galaxy. And so the thinking as it goes is that as galaxies merge together, they make larger and larger galaxy. And so this will end up looking like an elliptical kind of football-shaped galaxy. Another thing they found in the gas is the types of elements that they saw in the gas tell you that there are a lot of supernovae going on at this time, particularly core collapse supernova. That means massive stars go boom at the end of their very short lives, and that is what's populating and filling this cool X-ray gas. So it's a gorgeous image showing the violence of a galaxy merger, both in optical and the fallout in X-ray, which is pretty cool.
Yeah, just a stunning image.
Yes.
Oh, okay. So we just muted David, but
oh, sorry. Yeah,
it's okay. We're gonna get back. We're gonna talk to David in a second here. So now, David, you just warned people to watch for the sky falling on Universe Today. So
it depends which one. Are you talking about the Eta Aquarids meteor?
Yeah, Aquarids. Yeah.
Well, we're going to have a pretty good meteor shower coming this weekend. The peak is going to fall on Monday, on May 6th. Eastern Europe and longitudes east of that are going to see a better meteor shower. But I've been watching every morning when it's clear anyway, which isn't very often here in May in Florida. But the zenithal hourly rate's pretty good on this meteor shower. It's 55 meteors per hour. Keep in mind that zenithal hourly rate is an ideal rate. You probably won't see 55 meteors per hour from any actual location. That's what the amount of meteors you would see if the zenith was directly overhead, you had perfectly dark skies, and the meteor shower was at its peak, which nobody has that kind of optimal condition. So you'll probably see one every 5 or 6 minutes. This comes from the constellation Aquarius. That's why they call them the Aquarids.
So that's about the same. I'm trying to think as like a good Perseids shower.
Yeah, this meteor shower seems to be on a 12-year peak. I don't know why this one isn't as well known as the Perseids. It seems like 2009 it had an outburst of about 100 per hour, and we're on that 12-year cycle where it's getting weaker. But 55 to 60 per hour is still pretty respectable. And this is one of the very few that the southern hemisphere can join in on too. For some reason they don't quite understand, most of the major showers, the radiants are in the northern hemisphere. I've never seen a reason, or if that's just coincidence. But.
And what's the source of this one?
This one is Comet Halley.
This is Halley, okay,
yes.
Right.
And this is it's interesting you bring that up because Comet Halley is also a source of the Orionids in October too. It's one of the very few comets that we get 2 meteor showers from.
Oh, that's great. Yeah, no, I don't know. Like the Perseids are I think the most famous one, just because it's so nice and warm in the northern hemisphere.
It's the right time, yeah.
During the Perseids, so it's great to go outside and everyone's in their sleeping bags, and you look up the sky and
it's weird. The Lyrids a few weeks ago made a lot of news, and they weren't really that spectacular. It's strange how the news cycle and the media cycle goes with meteor showers. How they just get picked up by the right sources, and everybody starts talking about them. But this one is probably better, and it's not really being talked about that much.
So can you give people some just general advice on if they want to enjoy a nice meteor shower? What should they do?
Watch in the morning. In the morning, you're going to see more meteors. I always liken it when I'm telling people at star parties that think of a car driving down the highway. You get more bugs and mosquitoes on the front windshield than you get on the back. The Earth, after midnight, is facing forward in its orbit, so it's plowing into the meteor stream. You'll see a few in the evening, but you'll notice evening meteors, they have to catch up to the Earth because they're hitting the back windshield. So they can still do it, but you get those long, slow trains before local midnight, and then after local midnight, you start getting those head-on meteors where they're coming in. This meteor shower actually has a very fast velocity, too. It's 66 kilometers per second, I believe. One of the faster meteor showers, so you're going to see a lot of fast, quick meteors and fireballs.
That's great. All right. Well, we're going to move on then. So, Alan, you had a story this week about the test of the X-51, I think just today, right?
Oh, yeah. Well, it happened on May 1st, Wednesday, but the Pentagon didn't really release the full details about it until today. Aviation Week had a little bit on it yesterday. So this is the last test of the X-51A. It's a hypersonic aircraft. It's designed to go above Mach 5, and it's been a $300 million 9-year development program, and they have 4 X-51As that they've tested. This is the last one. The first 3, the first one did okay. The second one didn't do so well. The third one was just terrible, that there was a fin that came loose and the vehicle was lost less than a minute after it was launched. And so they had to investigate that for months to find out what happened. But today it went off just fine. Everything went by the book. They had a flight of about 6 minutes or so. With this test vehicle, what you do is that you put it basically on a solid rocket booster, kind of like a cruise missile. You fire it from a B-52. It gets to maybe Mach 4.8, and then this little, it looks like it's called the Wave Rider, and then one of my friends on Twitter said, hey, it should look like a surfboard if you're going to call it the Wave Rider, and it really does look sort of like a surfboard. It's very, very aerodynamic, and what happens is that you light it up, and you've got kind of this the atmosphere going through the ramjet at supersonic speeds, and so they've compared it to igniting a match in a hurricane. But it worked, and when it, like I say, Mach 5, and splashed into the Pacific Ocean when the test was done. So a lot of people talk about how, oh, this is going to lead to hypersonic airplanes. We're going to be able to go from New York to London in an hour, and maybe this technology will lead to those sorts of civilian applications. But why the military is doing this is so that they have hypersonic, super fast cruise missiles, and so that's where you're going to see this technology applied first. In fact, they already have a program at the Air Force Research Laboratory to work on hypersonic weapons, and so the next generation of Star Wars is a little bit closer because of this week's test.
Now, Alan, from what I understand, now I'm no aerodynamicist or anything like that.
Neither am I.
One of the really difficult parts of achieving those hypersonic speeds, it's not just to go a little faster, a little faster, a little faster. It's that the getting the fuel to go through the engines at that speed starts to get really crazy once you reach a kind of a certain threshold, and it starts doing all sorts of tricky things, and that's kind of what they're trying to accomplish with these new engines, right?
Yeah, that's right. As I said, you're already having this cruise missile basically that's going supersonic, and the engine won't work unless you get up to those hypersonic speeds. And so there's a lot of tricky aerodynamics that go into how this scramjet works. Scramjet is short for supersonic combustion ramjet. So it's a technology that a lot of people have been working on. They've been able to do it with hydrogen-based fuel, but this particular project used a hydrocarbon fuel, a jet fuel that's a little more stable, and so they think that this is more the way to go than a hydrogen-based system. So a lot of the aerodynamics geeks really get into this. I just have to kind of follow where they lead.
Well, you get a couple of advantages, if I understand. One is the speed, and the other advantage is this: you don't need to carry your oxidizer in the way that you do with regular fuel, because you're essentially taking the air and you're hitting it so fast that you're pressurizing the air as it's flowing through the engine, and then you're able to then mix it with your fuel. And so you don't, when you typically carry jet fuel, you're carrying both the fuel and you're having to, you have to carry additional weight. So you're going to get all these additional advantages if you can cross that speed. But boy, eventually, what, Mach 20? I mean, I don't think that'll ever be really that comfortable as a passenger ride,
Well, this is what they thought was going to happen with the X-15 in 50s, and it didn't. So I wouldn't be surprised if it didn't happen now. But it's,
Right.
Is it
supersonic,
less comfortable than a
tiny
12-hour
flight.
flight? That's the question.
I think I would still probably choose the 12-hour flight over the
Yeah,
only if there's
1-hour ballistic trajectory
1 hour.
at
1 hour.
Mach
Yeah.
20.
I think it's going to be a long time before you see this carrying people. I think one of the other applications they've talked about is delivery, whether you're delivering a bomb or whether you're delivering super duper Federal Express. That's a possibility. That's if you really absolutely need to have it over there in an hour.
Yeah.
I guess you could use
I
this.
see Amazon putting money into this.
But obviously from a war perspective, right? The current situation is that, if the Americans detect the Russians having launched a bunch of nuclear missiles at them, they can launch a bunch back. So you get this kind of balance of power. But if you get these man, what an awful thing, scramjet nuclear missiles, then there's really no warning. You just you press a button and 45 minutes later, the other side of the Earth explodes. There's no way to sort of to have that defense against it. So I think that's why they want it, and it's awful.
Yeah,
But,
yeah.
So I would I would much rather have it being delivering strawberries halfway across the Earth in an hour. Fresh picked strawberries.
Let's work on that,
In an
Fraser.
hour, in 45 minutes. Yeah.
The strawberry scramjet.
Cranberries.
Exactly. As opposed to nuclear missiles with no defense. I think that's the final end game of this. So,
If nothing else, Strawberry Scramjet would be a great band name.
I dig it.
All right, so we're going to move on. Amy, you've got a story about exoplanet habitability.
Right. So kind of an interesting paper came out, I think yesterday it was published, urging, what was the sorry, I'm just going to look up the scientist's name. Apologize.
Sarah Seeger.
Sarah Seeger from MIT is calling for exoplanet researchers to broaden their view of habitable life in searching for exoplanet life forms. So the idea in the whole sort of search for exoplanets thing is that we're always kind of looking for Earth-like things, right? We're always we know the life that we have on Earth. We know the things that it takes to have life on Earth. So let's look for that elsewhere because that makes sense. But she's saying that there are so many different types of exoplanets that there are between 700 or 800 exoplanets have already been identified. A fraction of a handful of those are possibly Earth-like. That there's such variety in the types of exoplanets that we're seeing, we should start to vary our definition of life-bearing characteristics and types of life forms to include all of these different kinds of exoplanets. So I'm sort of not surprised that this news has come out, and it's kind of interesting that a lot of people I'm seeing are sort of saying that it's absolutely crazy to be looking for non-Earth-like, or to be looking for life on non-Earth-like planets, but I would think that the existence of life around the hydrothermal vents on Earth is proof enough that you can find life in these extreme environments, like on rogue planets, just kind of wandering alone. If they have some kind of inner heat source, why not? There's all kinds of different forms that some kind of life could take, and I'm not a biochemist, so I won't say that it could be non-carbon based, but it could theoretically, right?
But in addition to just life that could live in the extreme environments here on Earth, there's also there was an astrobiology report out a couple of years ago from NASA talking about that life could use different kinds of solvent than just water. So instead of using water as the basis of its life, you could imagine extreme forms of life that use liquid ammonia, liquid methane, things like that as the solvent for the life, and that really expands out the kinds of life forms that you can have.
Really changes the so-called Goldilocks zone, because we always look for the Goldilocks zone, right, where liquid water can exist on the planet's surface, but taking other elements that could exist in the liquid form and could possibly support life would just massively expand the habitable zone. And if we could figure out what to look for and sort of how to figure out where, what signs of life there would be on those extreme alien environments, we could maybe find something easier or sooner. And especially the Earth-like planets are the small ones that are really hard to find. The Jupiter-sized planets, we can see those easier. We have a higher chance of maybe finding something good in there. So,
or what if those Jupiter planets have moons? Those.
Yeah.
We're looking at our own
They would
solar
be
system
really hard
with moons around those gas giants. So why not somewhere else?
A lot of talk about that. Yeah, exomoons.
Yeah.
But by
even our
what
own
method,
moon.
though, right? By what method would we search for life around these other planets? Because, we really, I mean, the only real feasible way, apart from listening to radio signals from them, right? The only real feasible way to detect life around another planet is to examine the atmosphere of that planet from afar, look for some kind of gas in the atmosphere that, could only be the product of either an advanced civilization or life, like, oxygen in the atmosphere or pollution in the atmosphere. But there's no telescope that can do that right now.
Yeah.
If we saw like the spectra of chlorophyll, for example, that would be something that we only know life can produce here.
Yeah, and I mean, I've been ranting about this for years, especially since they canceled the terrestrial planet finder, right? This was the mission that would follow up on the James Webb, that would be able to do exactly this thing. It would be able to detect the atmospheres, study the atmospheres of exoplanets, and be able to actually tell you whether or not there was life there. It would, like, you would be able to look at some of these planets and be able to say, yeah, that's a good candidate for life. So, I mean, I think it's great to expand the classifications for what's possible, but if there's no mission that will actually help us know what's possible, what's out there for real, then I don't know. It's like,
I mean, it's good. I think it's good to sort of take us out of this very narrow focus of looking for us in the universe, when we're pretty rare. Even on Earth, there's way more microbes than people. We should be looking for the microbes. But yeah, I'm not totally sure what's going to come of it. So it'll be interesting.
We have a hard enough time funding planetary science in our own solar system.
And I've seen a lot of people.
Not to be solar system centric or anything, but I mean,
apparently you are.
The money, we need to get the money to dig up. We need to dig up the money to go explore the places that we can actually go to right now, and never mind looking or figuring out if it's somewhere else.
Yeah, I really think if we're going to start getting into this broader search for life, we got to start with what we have access to, like Europa and Titan, and actually put more money into those, because we can do that within a lifetime, not 80 lifetimes.
Well, what she's saying here is that even if you say we're going to use liquid water as an indicator of habitability, you have to assign a probability to the planet. It's not just in the Goldilocks zone, out of the Goldilocks zone. There are lots of things going on with the planet, how it's working, how big it is, where it is in its orbit, how elliptical is the orbit, all these things. She actually is proposing more of like a triage or a probability assignment to how likely it is that these, can have liquid water, not just based on that Goldilocks zone hypothesis, and then pointing something like James Webb or something larger to look for these gases in the atmosphere.
We just need that observatory. We need that telescope to get launched.
I'm always kind of skeptical when they say the latest Earth-like planet or super-Earth has been found too, because I always point out that from a distance, Venus would look like Earth if we put it in another solar system. But Venus is very different than Earth. So.
Yeah, and so would Mars.
Yeah.
All right, let's move on. So we need like a sad trombone noise for the Herschel shutdown. Wah, wah. Wah, so, wah. I'm sure there's one somewhere. Nicole, you've been watching poor Herschel get shut down.
Poor Herschel, but Herschel had a very successful mission. So Herschel is a joint mission between NASA and ESA, so the European and American space agencies. It's an infrared telescope, which means it's looking at light that has a wavelength longer than that of visible light. And so it sees certain things. It sees warm dust. It could see forming planets. And in order to look at infrared light, you have to cool your detectors, cool parts of the telescope down. I think they use liquid helium on this mission. And so, as expected, the liquid helium eventually will run out. And as expected, it ran out right about the time it was supposed to. And so now that it's run out of helium, they can't observe anymore because the noise on the detector is far too high. Basically, if you have a telescope that sees warm things and the telescope itself is warm, it can't really see anything. It's like shining a flashlight down, the barrel of your Cassegrain telescope.
But I know with Spitzer they did a cold mission and then they did a warmer mission as well. Right. Did they do that with Herschel? Herschel,
I don't think it's observing at wavelengths short enough to work in a warm mission. I think it's only using the mid-infrared wavelengths, and those require the liquid coolant. So that's why
WISE did that too, correct? They did like a little closer look.
Yeah, so when the coolant runs out, you can still work in some frequencies, or wavelengths, but not in others. And so I don't think Herschel was equipped with those detectors, which is why it's can't be used anymore. But it did some really awesome stuff, detecting star-making material, working with Spitzer to discover the asteroid belt around the bright star Vega, and looking at intense star formation in distant galaxies. So Herschel did awesome stuff, but is at its end of its expected lifetime.
All right, so David, now I've heard that Comet Ison is going to destroy the Earth. Is this true?
Sure.
No. Wait, what? No, wait.
No,
it's a conspiracy.
It seems to be the latest thing going around the web, and I didn't realize this till Nancy shot it to me, that I guess they're winding up already pretty early on Comet Ison. And it seems like they're just recycling a lot of the Hale-Bopp type stuff, too, where they're talking about, there was a video that went around that an amateur took of an animation, a GIF animation he did of Comet Ison, and they're claiming they're seeing objects moving behind it.
Oh,
now when I know it's the same, it's like Hale-Bopp Redux kind of.
Yeah, at Comet Elenin, I mean, we just see it.
It was really bad.
Again and again.
You know,
It
whenever somebody sends me a video of something being, I'm a fairly advanced observer. I usually, before I read any comments or any kind of theories on it, I go and just give it my own look at and think, what do I think it is? Then I start reading the comment and see how many people agree with me. It's this one almost certainly is what they call hot pixels in the camera. And you can see it in the animation because these are GIFs and they're just individual still shot frames. You can actually see, well, they're saying, well, it's moving with it, but it's like, yeah, it's the camera tracking the comet, not the other way around. It's actually hot pixels, not cosmic ray hit pixels, but it's just some kind of defects in the my DSLR has a few little pixels I usually have to erase out. That's common with detectors. So it's,
now, Alan, you have been reporting on this stuff longer than I think anybody I know. And how many times have you debunked, object in space is, Planet X and going to destroy us all?
Well, I got to say that Ian O'Neill has been doing a great job, and Phil Plait, and
Yep.
there are all
They're
sorts
not
of
here.
people who are not, but we all do this.
I know, we all do.
That's part of the job, and so David did a great job with Comet Ison, and there has been Comet Elenin, and actually I did cover Comet Hale-Bopp and talked with one of the guys who was part of that suicide cult but missed the appointment. And unfortunately, he took his own life later. Just couldn't cope with this whole crazy thing. So, and you've got 2012. That's a huge thing, and the Large Hadron Collider. But it's serious stuff. We laugh at it, but there have been people who have done kind of desperate things because they took it seriously, and so we got to continue with this.
Well, we did a whole series on the 2012. Actually, I originally assigned all those 2012 stories to Ian O'Neill, and that's how we got into this whole as a career. But I mean, we just got so many emails. Like, we were just getting email after email from, and in some cases, they were really heartbreaking stuff. I mean, we would get emails from children, from teenagers saying, "I'm so scared. Am I going to die?" Because of 2012, and you just kind of go, no, everything's fine, and then look at this really important article that we've written that really debunks everything, and yet they keep coming back. So I mean, I don't know. I mean, the people who are digging up these stories, it's just like clockwork. Like, you see a new comment, and like, I knew, we could have. What's that? Yeah.
They get Dave Yeomans to come in. He knows everything about everything that's flying around the near Earth area. David Morrison, comes in. He talks about stuff, and still there are those who will say, no, those guys are liars, and they will they will come right out and say, those guys are liars. Here's the truth. And so you can understand where people who don't follow science and astronomy as part of their daily life, they don't understand. They go, well, who's right? Who's right? Who should I trust?
That's a default position, that they go back to. Like I was telling you, it's like we were already called a shill for NASA basically this past.
Well, and I was hoping that 2012 would have been such a public mistake
No.
that, so many people were expecting the end of the world in 2012, and it just didn't happen. It's just business as usual. That would give people a tiny little bit, like a vaccination against those conspiracy
That's
theories.
a bad word, considering that there are vaccination conspiracies.
Yeah.
Yeah, I know, but I still, just like you said the world was going to end in 2012 and nothing happened, so now we're a little numb to this.
Do you have it? But look, there's a Wikipedia page on a list of dates predicted for apocalyptic events. This page is huge. This is not new, people predicting the end of the world.
Oh, yeah.
I mean,
Almost every bright comet has had its...
but 2012 was the Gangnam Style of media, right? Right? Of apocalypse. So in other words, if you think of what is the piece of media that has been seen by more human beings, it is Gangnam Style. We have all seen it, and more than Shakespeare, more than anything. And so 2012 was so well publicized, leading up to 2012, that I really feel like it really kind of passed through almost everybody's brains.
Frankly, I think it did have an effect. You're always going to have, every generation has a doomsday date. Y2K, you go back to the Great Disappointment of 1847 or so. So you're always going to have this, but these big events, do have an effect on that generation. Now, in the next generation, there will be another big doomsday event, no doubt. But I feel like after 2012, it hasn't been as played up as it was before. And I think actually the rapture, if you remember the rapture, I think that had an effect as well. I think people saw that there were a lot of people who took it very seriously, and then nothing happened, and so they know that this is how the event is going to go down.
You remember the Jupiter effect in the 80s, the 1980s? Jupiter was supposed to pull us up our axis there.
Right, and the grand convergence, you get these things every couple of years.
Age of Aquarius. GeForce 833 asks, so how long until someone claims that Comet Ison is actually the planet Nibiru? It's already happened.
It's done.
Yeah. In fact, that is the story that David worked on Universe Today.
Days.
Yeah.
I've had people ask me on Google Earth, when you go on Google Sky, it's like that why are there areas blacked out on Google Sky? It's like, what's NASA hiding if you can't? It's like, so there's entries in the data that has gaps. I mean, there are amateurs out there scanning the skies every night with massive telescopes. I mean, we couldn't hide something like that. There would be no way that you could hide something like that.
Tom Nath adds, a brief history of the apocalypse goes back nearly 4,000 years. As long as there's been a world, someone's been predicting the end of it.
All right, but let's get to some real science, which is Matthew. You wrote a post about antimatter, anti-gravity.
Yeah, so this is a really cool story, but unfortunately we're not even in the first chapter. We're kind of in the prologue to the story.
I should have air quoted real science, speculative science.
But it's really interesting. It's the idea which has been floated, a few times, that antimatter, which every type of particle has a kind of a mirror image version, has opposite electrical charge, but there's the idea that maybe it also has the opposite gravitational effect. So in other words, if you could somehow construct a weight out of antimatter, it would fall up instead of down. Now, the thing is, it's really hard to make that much antimatter in one place. We have a lot of trouble making even individual antihydrogen atoms, and that's the lightest element that there can be. And so it is actually not, it's actually remarkably hard to test the gravitational effects on antimatter. But researchers working with the ALPHA experiment at CERN, despite the fact that it's all capitalized, I don't believe it's an acronym. I haven't found a description of it, but it's called ALPHA, and it's an antihydrogen trap. What they do is they cool down antimatter particles and then entice them into forming antihydrogen atoms for a variety of experiments. And they figured out that, hey, as these antihydrogen atoms escape from the trap, maybe we can see whether they preferentially go up or down. And so far, all they have is the data that's already been collected. So they weren't doing a specific experiment on the antihydrogen. They're just seeing whether the existing data shows falling up or falling down, and even more to the point, whether the mass of the antihydrogen, the gravitational mass, the force of gravity acting on it, is the same as the inertial mass, how hard it is to steer an antimatter particle. So that's what's called the equivalence principle. We know that pretty well for matter, but for antimatter it's really hard to test. So sort of two things in one. But the preliminary results are completely and utterly inconclusive, can't tell a thing. But that doesn't mean that in the future, with knowing what we're looking for, we couldn't go and design specific experiments to do this. And so that's really what this experiment, the value of this experiment is.
What would be the implications if it does fall up and not down?
Well, that is a really interesting thing, because there's a lot more matter than there is antimatter in the universe. But with enough of this antimatter around, if it did have anti-gravity, then it could possibly help explain stuff like why the expansion of the universe is accelerating. It could have something to do with dark energy. Possibly. And again, that's not a given. Even if it falls up, it doesn't necessarily mean that it's going to solve all the problems we have with cosmology.
But wouldn't you also get the situation where I guess the antimatter is being repelled by gravitational objects? So you're not seeing the annihilation, so it would help sort of explain maybe where it's hidden?
Possibly. But again, that's a question of how much, how gravity is the weakest force in the universe. So a lot of other things are going to affect it before gravity is going to be the primary thing. It's going to, if it has anti-gravity, it's going to tend to be most important on the biggest scales, the biggest objects, and on the scale of the universe as a whole. So it won't tend to make as much difference on, as far, again, as this is as far as I can tell. Other people may be able to chime in, but it's not going to make as big a difference, say, on the scale of the Milky Way.
But we could build spaceships out of antimatter and then just release them like balloons, and they would just float off into space, right?
Yeah, if you could figure out how to
hit something.
Yeah, you want to get you couldn't fly in the spaceship.
It would repel.
No, it would just be like a balloon. It would be a balloon at the top of the spaceship.
You just can't touch your spaceship.
Yeah, you don't touch your spaceship. You hold a big balloon, and then you hold it in some kind of magnetic field, and you attach your spaceship to it, and then you just off into space.
Oh,
like
given we have yet to make a single gram of antimatter. We have yet to make a single tiny gram of antimatter. You have good luck with that, Fraser.
I just have a bountiful imagination.
Yes.
All right, let's move on. Okay, so, and this is cool for those of us Canadians here in this
Blame Canada.
in this episode, which is that they put space robots on the $5 Canadian bill, and I don't have one yet, but
They're not in circulation till November.
No, okay. But have you got a picture, Alan? You report on this, right?
There's a.
Yeah. Oh, yeah.
Or Amy did, but
I posted it.
Go for it. Yeah, go for it, Amy.
It was pretty cool.
Sorry, I wasn't prepared.
Shall we sing "O Canada" while we're waiting?
Blame Canada.
But I guess if people don't
picture.
know, the Canadians' sort of contribution to space exploration is that we built the Canada arm for the space shuttle, and we built the sort of robot arm version on the International Space Station.
There's your arm.
And it's being
on our money.
Did
it's
I
being
do-
celebrated.
U.S. has the worst
Okay.
money ever.
There you
we
go.
Did I screen share?
Now the Canadian money, if you've never seen
but
it, it's
after
kind
I
of
did.
neat. That part where it's white there is actually clear plastic, so you can actually see right through the money.
Mm-hmm.
And the whole bill is actually very plasticky feeling to it. And I guess it's chock filled with holograms and all kinds of other. And there's Braille. You can see up in the upper right corner there. There's Braille.
There's a little bit of antimatter inside
A
of
little
it.
bit of antimatter, yeah, just to prevent
Canadians
counterfeiting.
figured out antimatter.
Yeah.
We have too many Canadians in this hangout.
You can never have too many Canadians.
Okay, fair enough.
We want space on American money.
We should have space.
Yeah, you should have space on America. Well, that's the terrible
there's
irony.
an astronaut on the Ohio quarter.
That's right. That's right. And there is Benjamin
there's-
Franklin is kind of a scientist, I guess. It's,
Yeah.
the closest
And
we have
the
to a
Wright
scientist.
Flyer is on a quarter.
So we're starting to run out of time, but I got two more stories that we
We've
wanted
got
to
a couple
quickly
of
look
questions
at.
as well to get to.
Oh, do you want to hit the questions?
Sure. What was the first one I posted a while back? Somebody was asking. Oh, I don't know where it
It was a
went.
question for
Oh,
Amy,
Ole
wasn't
Olson asked if we find meteorite fragments, where
I
should
saw
we
that.
send them?
If they're talking about the Edda
eBay?
Aquarids, yeah.
If they ever come across a rock that seems,
Okay.
what do they do?
I don't know if that's related to the Edda Aquarids, but you won't find any fragments of that because they're common. Like,
Okay, but if you do, what should you do if you think you have found a meteorite fragment?
I would DM Jeffrey Notkin at the Meteorite Men and say, hey, what do I do with this?
Okay, meteorite men. A lot of them show up at universities. They come to
Yeah.
the physics department or geology departments at universities and say, hey.
It's pretty tough, if I understand right, that, for it to be a stony meteorite, it looks a lot like a rock. And
Yes.
it's pretty tough to be able to distinguish between a rock and a meteorite.
And it's hard to distinguish between an iron meteorite and iron slag from a factory as well. That's
Yeah.
a lot of fake meteorites, or aka meteor wrongs, are come from factories.
Yeah. Not the ones that Phil Plate hands out, though. Those are
Or you.
legit. Well,
Is
that's
the
through
one
Phil
from you
Plate.
legit?
Yeah.
No,
Yeah.
no meteorites have ever been associated with a meteor shower. I learned that
Here's
from
my
Jeffrey.
meteorite.
My-
Fine.
Nice.
Oh, cool.
Fraser hands it out like candy.
Okay, so we got a cool picture of a bullet hole in the ISS solar array.
Yes. Well, I'll just
I could put that up.
pop it up. Oh, I dug it up, so it's.
Oh, you got it.
We actually covered this
shortly.
in the in our episode of Astronomy Cast. We talked about ISS and talked about the about this hole, but yeah. Go,
Yeah,
Jason,
well,
go.
it was a couple of days ago, and Commander Chris Hadfield, another Canadian astronaut, he's the Expedition 35 commander, and he tweeted this photo of the solar arrays on the ISS, and in one of them you can see this little bright spot, which is basically looking through where I don't know if it was micro or not, where a meteoroid had punched through it, and there it is. I'm going to shut mine off so it doesn't pop up. Had punched through it and left a good-sized hole in there. Now, I'm not quite sure, and I've looked to see if I could find how big those individual solar cells are. I'm not quite sure. The only thing I found was that all in all, there's an acre of solar panels across the space station. But regardless, something hit that, and Chris Hadfield said, "Glad it missed the hull." And I'm sure that that would have been a. Now I'm not quite sure if something that size would have done any major damage to the hull, or if it would have just got sunken into some of the many layers that they have surrounding the inhabited sections. Regardless, it reminds you that there's stuff flying around up there all the time, and I believe he also used the term a bullet hole. And actually, if you think about it, whatever hit that was going much faster than any bullets fly here on Earth. Your average rifle bullet goes about 1,000 to 2,000 miles an hour. Usually they're measured in feet per second, but for the sake of argument here, it goes about 1,000 to 2,000 miles per hour. Out in orbit, meteors are coming in at about 25,000 miles an hour. So, and upwards of that. So, and even the space station itself is going, 17,500 miles an hour. So, everything's going super fast up there. Whenever this happened, it would have just been an instantaneous event.
I had a picture up in one of our last hangouts that showed a block of aluminum with a gigantic crater dug out of it by a 9-gram object that was sort of fired at the aluminum at the speed that these things move in space. I mean, it was catastrophic. It was a gigantic amount of damage.
Now, somebody suggested that this could have been a piece of space junk that's in orbit, a little bit of debris from who knows what, or it could have been something that came in from somewhere else in the solar system. we really wouldn't know because everything out there is going really, really fast.
But I think, I mean, if this hit an astronaut, for example, it would be a bad day.
Yeah, this would be not something you would want impacting you if you were out on EVA doing a little repair on the outside of the, on the outside of one of the units there.
Yeah, and so I mean, this is one of the risks that they're ready for. That your number might come up at some point, and these bullets are zipping past the space station all the time.
Mm-hmm.
Yeah. All right, we've got one last sort of notice for people, and I think David, you've got this, which is the upcoming annular solar eclipse.
Yes, there is an annular solar eclipse next Thursday, Friday. It crosses the international date line going from Australia through the South Pacific, and it's going to end in the Eastern Pacific. It's going to cross the same path as the total solar eclipse we had over Australia last year. Well, it's going to crisscross that same path. And Hawaii is going to see it as a deep partial to about a 50% partial. So Hawaii will get some of the islands in the Pacific will get it as well.
Will we get it here on the west coast of
No,
North America?
It barely misses the west coast. The sun will set before
Right.
we get any of the partial phases. The place to be would be just northwest of Ayers Rock in Australia, like Western Australia and the Northwest Territories would be the best place to catch it. It's an annular, so it's not going to be a total. So.
Right. Just for people who aren't aware of the difference between an annular and a total solar eclipse.
Oh, for an annular eclipse, the moon is actually too far away to cover the sun. It's just barely, you're going to get like a bright ring around it. And I want to mention, too, that during an annular eclipse, you also have to take precautions to use these throughout the eclipse. Either these or some kind of safe, approved protection, because unlike a total eclipse, when it's in totality, you can take your eclipse glasses off and look at that. But you have to actually protect yourself, because even though it's only about 5% of the sun, I've seen an annular from Lake Erie in 1994, and 5% of the sun is still really, really bright. It's about 20,000 times brighter than the full moon, so it's brighter than you would think.
Just a show of hands here, who's seen a total solar eclipse?
I have not, believe it or not.
Alan. No, neither have I.
Aw.
Only Alan. Yeah.
2017?
2017, we will
2017,
all
yeah.
see one.
Yeah, I
Party in
will.
St. Louis, guys! Everyone, come on!
Hooray!
I'm thinking Columbia, South Carolina, maybe where
Well,
I'm
the spot where the 2017 eclipse and the 2024 eclipse, I think, cross
Illinois. Yep.
30 miles from here. Yeah, so
Yeah,
we're going to
right
try and observe
around-
both eclipses from the same spot.
Right
I
around
think Eastern
Carbondale.
Oregon is where I'm going to go for it.
Yeah, Carbondale, Illinois. There's
That
another
sounds good,
one-
Fraser. Maybe I'll go with you.
Yeah,
How about that?
we'll do that. We'll do a party there in Eastern Oregon. All right, cool. Well, let's wrap this up then. So everybody, Alan, where do we see more Alan Boyle?
Well, right now it's cosmiclog.com. That's the easy way to put it. And on Twitter, I'm B0YLE. Remember the zero.
Remember the zero. Amy, share a title.
You can find my blog, Vintage Space, just Google it, or my website, amyshearertitle.com. I'm also all around the social media, Discovery News, Motherboard Device, Al Jazeera English, and Scientific American.
You really are. You are the hardest working journalist.
Paying my bills.
David.
I am currently routine contributor to Canada.com, listthesword.com, universetoday.com, my own site, AstroGuys with a Z, and I have an article coming up in Sky and Telescope. Yay.
Nice. About what?
It's going to be about social media and astronomy. I can release that. It's going to be out there, but we're going to have a bit about the virtual star party in there.
Nice.
As well. So.
That's great. All right, Jason.
Well, like it says down there, I'm at lightsinthedark.com. I'm also writing on Universe Today, Discovery News Space, and you can find me on Twitter at JPMajor.
All right. Dr. Matthew Francis.
You always say doctor. I guess it's because it's my Twitter handle.
Are you or are you not a PhD astronomer, astrophysicist?
I am a post-hole digger, yes. I'm a PhD.
Child R&D.
That is, I'm sorry, I'm hardwired.
No, he's very good about
I
the
do
doctor
the
thing. I like
same
it.
for Nicole.
I love
Yes,
it.
This is true. You can find me at Bowler Hat Science, Galileo's Pendulum. Those are both .org, by the way, and write for Ars Technica, BBC Future, and now New Yorker.
Nice. All right. And Dr. Nicole Gallucci.
Hi, I work for CosmoQuest Burst. I'm the postdoc there, and I write for Discovery and Skeptic and School of Doubt, which is an education blog, and I can't remember what else. Probably just mine, noisyastronomer.com.
Awesome. Okay, and so the next thing we're doing, I guess, is going to be the virtual star party, which is going to be on Sunday night, where you join me and Scott Lewis and a whole bunch of astronomers. We're going to give you a live view of the night sky with whatever is up, with whatever telescopes we can wrangle together. So join us on Sunday night when it gets dark on the West Coast, which is about 8:30 Pacific Standard Time or so.
Oh, I have an announcement as well. CosmoQuest classes. I know Matthew is teaching a cosmology class right now, but coming up soon we have a class on the sun and stellar evolution. That'll be taught by Ray Sanders. So if you go to cosmoquest.org/classes, that'll give you the information there, and you can sign up for that class.
Awesome.
Starting soon.
Yes.
All right. Well, thanks everyone for watching. Thanks everyone for joining us. This is a action-packed episode, so we'll see you all next week.
That happened on Monday. So Spaceship Two is launched underneath a mothership. It's not actually launched on a rocket like we're sort of used to seeing in spaceflight. So the mothership is flying. It drops the Spaceship Two, and on Monday it ignited its engine and actually went supersonic. I don't actually, off the top of my head, know how fast it went. If anybody has that link, they could pull it up. But it did go supersonic for about 16 seconds, I think, before its engine shut out, and then it came down for a landing. So that's a huge milestone because, of course, when Spaceship Two does eventually launch from a mothership and do the same trajectory to get into orbit, it's going to have to do that supersonically. So that it actually went supersonic on Monday is a pretty big milestone. So that's fun.
Now, Alan, were you there when they did the first test for Spaceship One? Did you actually see it get tested?
Yeah, 3 for all 3 flights. Yeah, June and then 2 kind of in the September-October time frame. Yeah.
But there wasn't a lot of advance notice that this was going to happen. It was pretty quiet, and then they did their test. I saw some rumors and sort of conversation that was going to happen, but they definitely didn't make a big to-do about it this time around.
No, actually they made more of a to-do about it this time around than they would have under Bert Rutan's tenure, because Bert was always, he didn't want to he wanted to make sure that it really worked, and so he didn't want to have all these journalists breathing down his neck as they do this stuff. So this time there was a little bit advance notice, but there's always a chance that they could call off the test. And even if a pilot sees that something doesn't look right before they do the drop, they don't have to light up the engine. They can just glide back down to a landing. So they want to give themselves as much leeway as possible.
And so when where are we on the timeline now compared to actually paying passengers getting a chance to fly in space?
Well, they're going to do a series of tests. This was the first test. They'll kind of build up to actually putting the test pilots above the 100-kilometer altitude mark, and that will be officially they're in space. But they expect that will happen by the end of the year, but it's going to take a little while longer for commercial operations to start up, and they expect that commercial operations will be in a different place at the Spaceport America space facility in New Mexico. So now they're saying that it's going to be early next year that Richard Branson and his family are going to climb aboard and be on that first commercial flight, but a lot of people have told me that it could take longer than that. It could be, even way back when, some people were betting it was going to be 2015, other people were betting it was going to be 2017. So it's nice to be optimistic, but also to be realistic and don't expect, don't set aside your vacation time yet for next year.
I heard they've also raised the price, right? Like, I think before it was $200,000 for a trip, and now I've heard they've raised it to $250,000. Yeah,
they're saying that it's likely that they will raise the price to $250,000 for a seat, and that may be sort of a marketing thing so that you get people interested in kind of getting the $200,000 deal. But eventually, everyone at Virgin Galactic has talked about how the price should eventually come down to about the price of an SUV or a very expensive vacation on Earth. So this is really kind of more of a marketing, let's talk about a price raise. Maybe they will raise the price for a while and then see how the market goes once you've got the early adopters flown.
So just a show of hands here, who would fly on Virgin Galactic?
Yeah, you bet.
Will you give me $250,000 for the ticket?
Yeah.
That's
Free
the
ticket.
assumption.
Free
Sure.
ticket.
It's got to be longer affordable.
So I was just noted on Facebook that the Spaceship Two hit a top speed of 2,500 miles per hour.
Yeah, according
In
to
this
Robert
test.
Herrick on YouTube, they hit Mach 1.2.
Oh, nice.
Oh, right. I forgot to mention that people can comment and and give us updates and answer our questions as well. So if you're watching this on Google Plus in the event page, you can post your comments there. If you're watching this somewhere in the streams, you can. I don't know if you got that one, Nicole, the one from your
Yep.
feed. Okay, yeah.
Oh,
you
I
can
don't know if I
post it.
shared it, but I have it.
Yeah, you can get it from if it's Nicole's stream, you can post a comment there. If you're watching this just somewhere embedded, you can use the hashtag.
Supernova, but a big hypernova. So this was spotted on April 27th. By the way, gamma ray bursts always have these really kind of a license plate name. So this one is, I even had to write it down, GRB 130427A, and that was found
It's
on
just
April.
the date.
You're right.
Yeah.
Wow. So it was the first one slain on that day. I never made that connection
Really?
before.
Oh, okay.
Theorist. Okay, but anyway, it was the longest. But what's interesting, though, of course, is because it's so bright, that means it's relatively close by. Relatively in cosmic terms, it's about 3.6 billion light years away. But a lot of gamma ray bursts are a lot farther away. So this one is very interesting because it was long enough that it could be observed both by the orbiting Fermi satellite, gamma ray satellite, but it could also be observed, follow-up observations by ground-based telescopes at the same time, which almost never happens. Usually gamma ray bursts flash and then fade, and then you kind of have to work backward and track them down. But this one actually successfully spotted, and so very exciting stuff. Means there's going to be a ton of data from it. Great thing, and it's one of those. One of those, oh my God type. I'll clean up what I was going to originally say. Oh my God moments. Really bright and awesome.
What was the visual magnitude on that?
I could not find optical data on it.
Okay.
I will see if I can track that down, and then we can add it later. But I couldn't. The press release just came out today,
Yeah.
and it doesn't link to a paper. And there's nothing on the archive about it. So I'm going to see if I can find a visual magnitude because I wanted to know that
What
answer
about
too.
Astronomer's Telegram? That might have it.
MIHL.
Yeah, I'll check.
Daniel Fisher, Cosmos for You, has been tweeting about this for days. So I think
Okay.
he links to a couple of the telegrams. So
Excellent.
I'm wondering if any imagers might have caught it, just on their random exposures.
So hi everyone, my name is Fraser Kane. I am the publisher of Universe Today. It's your weekly space hangout for Friday, May 3rd, 2013, and we have so many stories today. Again, we've got the brightest gamma ray burst ever, the test of the Virgin Galactic spacecraft, a cool storm on Saturn, collisions of galaxies spotted by Chandra, maybe a test of the X-51, an upcoming solar eclipse, and more and more and more. So we're going to get cracking. You can meet everybody who is joining us this week, and we've assembled an enormous team to talk about an enormous number of stories. So let's just get through it. So we've got Alan Boyle from Cosmic Log.
greetings.
Awesome. We've got Amy Title
Hello.
from Vintage Space and other places. We've got a new person joining us this week, which is David Dickinson.
Hey there.
David has written. You're at Astro Guys and also has done some writing for Universe Today. So awesome. We've got Jason Major.
Space.
We've got Dr. Matthew Francis. Oh, he's muted. Still muted.
There we go.
There we go.
2 places to mute.
I know. And we've got Dr. Nicole Gallucci,
Hello.
who is going to be producing this show and posting lots of cool pictures of all of the stories, posting up the story links and pictures as we come across them. So,
All the clicking.
all right. And Alan, I kicked a story your way. Is that fine? X-51. You want to talk about that?
Sure. All right.
Okay.
You want to start with that?
No, no.
Oh,
No,
oh,
no.
all
I
right,
just want to make
all
sure
right.
that you're okay to do that. If not, that you can prepare yourself mentally and emotionally for,
I'm ready.
for that.
Mentally
Okay,
and
good.
emotionally.
No, I think the first story we'll talk about is this really bright gamma ray burst, the brightest one ever. Dr. Francis.
All right, well, one moment. Let me bring up
I
the
can do that while
graphic.
you talk.
Okay, well, that
I can
works
share it
too.
while you talk.
You only
All
have
right.
to think and talk.
Yes.
You
All
don't
right.
have to also click and share.
All right, well, I will take it away then. All right, so this is the brightest gamma ray burst yet seen, and it's also the not coincidentally the longest duration gamma burst yet seen. So gamma ray bursts are, to our best knowledge, the explosion of very, very massive stars. So not just a
There was one
possible.
other gamma ray burst that hit visual, like naked eye visual magnitude a few
Yeah.
years
Yeah.
back,
I
so it's
remember
not
that one.
impossible.
Now, you know, I mean, if I understand correctly, right, gamma ray burst, the cause is essentially really large stars going kaboom, or, you know, compact objects colliding with one another. So,
right.
you know, was there anything special, or was it just a really extra big star that went kaboom?
It's just that it was extra big and extra long. So the fact that we've got more data from this than before. I'm not sure why it's just hitting now, since it happened on April 27th, why it's just hitting NASA press releases now. But
Well, I mean, a lot of the times this raw data is totally available, but
Yeah.
it takes sort of a certain mindset. Someone's got to be actually looking through it and trying to get a sense of it. But, you know, if it finally makes it through NASA's, you know, press release, then they're going to take it and they're going to write it up, and then we all start reporting on it because, you know, we weren't looking through the raw
Right.
logs from, you know, from the space telescopes, which maybe we should. I don't know.
although actually, if I can pick up on something that Fraser said, we can definitely rule out the possibility that this was another source of gamma ray bursts is two neutron stars colliding, two pulsars colliding. And the reason we can rule that out in this case is because the duration of the explosion was too long. Gamma ray bursts that come from collisions are short duration, and this was not that. So we can rule that out.
Fantastic.
And they expect to find, they expect to be able to see the supernova remnant that supernova of that caused it within a month.
Yes, which would be awesome.
And I think if you want to get a sense of the scale of like how much damage is getting done by a gamma ray burst, you should definitely pick up Phil Plate's book, Death from the Skies. He's got a great chapter just on gamma ray bursts, how you get essentially this horrible beam of energy that goes
That's
halfway
one
across the
here.
galaxy. There we go. And
Awesome book.
strips away your atmosphere in a heartbeat. So, yeah, no, a gamma ray burst, even if you're a whole half galaxy away, it is no protection from something this powerful. So amazing. All right, well, let's move on. We get so many stories. So Virgin Galactic did their first power test, and they broke the speed of sound. Amy.
Yeah,